This is 6.5 or compound interest, and it works on our recurrence relations. So, building upon the term before it and adding to. So, when we're looking at compound interest investments, the interest is calculated at the end of that time period. So, if you're looking here at numbers, we're talking about numbers of years. So, at the end of year zero, which would be time zero, there hasn't been any years completed, you may have an investment of $3,000. So the question up here is talking about which compares $3,000 invested at 5% per annum compound interest, compounding yearly to 5%, simple interest after the nth year. So when we're looking at compound interest, it's actually building upon. Last lesson we looked at simple interest, where we're adding the same amount each time. 5% of the initial rate of $3,000 was $150. So every year is exactly the same based on that first investment. A compound interest, on the other hand, is building upon the year before it. So if we're looking at year zero, we start at $3,000, we find $150 of interest is added to that. By the end of the first year, it equals $3,150. Then we use the $3,150 and add upon that. So if we're using, this actually should say 5 over 100, so 5% times, that should actually be 3,150. And what that then gives you is that 157.5. So after the end of the second year, your value goes up to 3,307.5 as opposed to 3,300. And you can see that gradually gets bigger. So you're using the end of the value of the investment of the year before, timesing it by 5% to adding that interest. Whereas the simple interest, we were adding 150 each year. It didn't change. Now, to sort of put that in layman's term, they're talking about the new value being the old value plus 5% of the new value. Of the old value, or the value of the year before. And we have a bit of a recurrence relationship sort of happening here, and a general rule. So to find your general rule, you have the VN plus 1, so the year that you're looking for is 1.05 because it's 5% more of the year before it. And so here's our recurrence relation. V0, or the initial value, is 3,000, and the years after it will be 1.05 VN of whatever value was the year before. So if the value is greater than 1, it means that the value is going up. If it's going to be less than 1, between 0 and 1, this number here, this R value, we'll see that in a minute, you'll see that the numbers will go down, and we'll have a look at that. So you can see as 5% of 3,000, we're adding 5%, so 5 to the power of 1, we end up having 3,000. If you keep building on that, you can see that that's after year 1, if you find that equation. That's after year 2, after year 3. So the general formula ends up being to the power of how many years. So let's have a look at the recurrence relation first. So you've got your starting value, which was that 3,000, and the year. R is 1 plus whatever your percentage is over 100. C is just the number of compounding periods per year. So if you're talking about monthly, that would be over 12. If you're talking about quarterly, that would be over 1. But usually it's in year, and in our case it was just 5 over 100. And the general rule, we use that rate, 1 plus 5%, which is 0.05, to the power of whatever year you're looking for. So this value and this value is the same. So the total number of compounding periods, or the total number of years usually. And when we're looking at that, as I said before, if R is bigger than 1, you're going to see a geometric growth, or you're going to actually see the curve moving up in this fashion. If you're going to draw a graph, if you've got a R value between 0 and 1, you'll go down. So it'll sort of curve down this way, and we'll see how that works. So example 1, Alan inherits $35,000 and decides to invest it in an account where he earns 6%, compounded monthly. All right, so that's really important when we're using our values here. So the rate per year is 6%, but the rate per month is 0.5% because we divide that by 12. We're talking compounding monthly divided by 12. That's that C value there. So when we write down the recurrence relation, we're going to find our R value is 1 plus the rate, which was 6%, divided by 12, so that we've done here, over 100. And that gives us a value of 1.005. So the half of percent is equivalent to this. So we've got 35,000 being our initial value, and the recurrence relation, so the Vn plus 1 is equal to 1.005 Vn. What's the rule? Now the rule, we just use the same R value down here and to the power of n times by 35,000. So recurrence relation has its starting value. Your general rule will have the value within the equation. Use the rule to find the value after 7 years. Now all we need to do is find n. Remember, it's compounding monthly, so we're doing 7 times 12, which gives us 84 compounding periods. So all that means is how many times are you actually applying that percentage to the value that you have. So in this case, okay, after 84 compounding amounts, we use the R value to the power of 84 times by 35,000, and you'll get this value here, 53,212.93. So after 7 years, you'll write that in. Now, when you're answering these questions, it's really important that if they're asking you, find the value of the investment, generally writing a full sentence explaining what you were looking for. So it says, what's the value of the investment after 7 years? The value after 7 years is $53,212.94. So that was the general example, and this is up for you to follow. What you'll also find, and I won't go